Hello. In this video, we want to cover a very basic topic when working with Allen-Bradley PLCs. Module identification. First of all, if you come across a new module, the first and most important thing to do is to read the complete part number. Not the number of LEDs, not the color of the housing, not even the number of terminals. The part number tells you everything. This number is usually printed on a white label at the top of the module or on the housing itself. Let us read an example together. Suppose you see this number, 1756 IB16. The first part, 1756, indicates the module family. In this case, it means ControlLogix. The second part, IB, specifies the module type. The letter I means input, and the letter B means digital. So this is a digital input module. And the last number, 16, indicates the number of points, or the number of input terminals. So this module has 16 digital inputs. Now, digital inputs really only have two states, 0 or 1. 0 means no signal is reaching the module, and 1 means voltage is applied to the corresponding terminal. Now where do this 0 and 1 come from? From the field devices that are connected to these inputs. For example, a limit switch, when actuated, closes the circuit and sends voltage to the PLC, which is the 1 signal. Or a push button, which activates the signal when pressed. Or a proximity sensor, which, without any physical contact, detects a metal object and changes its output, telling the module that an object is present. All of these are ultimately telling the PLC one thing: is my input 0 or 1 right now? And the PLC makes decisions based on this information. Now how can we tell, without software, whether an input is 0 or 1? Look at the LED indicators on the front of the module. Each input has its own dedicated LED. If it is on, it means a 1 signal has reached the module. If it is off, it means either the sensor has not been triggered or there is a problem in the wiring. And one very important point, always check the voltage of these inputs. Some modules are 24 volts DC and some are 120 volts AC. If you connect a sensor with the wrong voltage to the module, it will definitely damage it. Now let us take a closer look at this card. On the card, it is written, 1756 IB16. First of all, we see 1756. This number indicates that the card belongs to the ControlLogix family. Then we get to the IB part. I means input. And B in this code specifies the digital module type. So we are dealing with a digital input module. Now we come to the number 16. This number tells us that this card has 16 points or 16 digital inputs. This means we can connect signals from equipment such as limit switches, push buttons, and proximity sensors to the inputs of this card. So if you come across a 1756 IB16 card in a cabinet, you can quickly say, ControlLogix, digital input, 16 points. But remember one important point. To know the full specifications of the card, such as operating voltage, wiring type, and other technical details, we need to check the complete part number with the manufacturer's datasheet. So in practical work, we do not rely only on the appearance of the card. We read the full card number and verify its specifications. In the previous part, we identified the digital input module. Now it is time for the digital output module. Here we see a 1756 OB16 module. Again, we have the same part number rule. 1756 means the ControlLogix family. But instead of IB, here we see OB. O means output. And the number 16 means 16 output points. So 1756 OB16 is a digital output module with 16 points. Now, inputs used to receive 0 and 1 from field equipment. But outputs work the opposite way. The PLC decides which of these 16 points should receive voltage or not. The same 0 and 1, but this time going from the PLC to the equipment. What are these outputs connected to? Common examples are a solenoid valve, which cuts or connects the flow of fluid. An intermediate relay, which switches power circuits with low power. A contactor, which is used to turn large motors on and off. An indicator lamp for status indication. A motor starter for starting electric motors. And a buzzer or siren for alarms. All of these are powered by the same 0 or 1 signal from the output module. Just like the input module, here we also have LED indicators. If the LED for a point is on, it means the PLC has applied voltage to that output. If it is off, it means the off command has been issued. But there is an important difference: output modules usually handle more current than inputs, but they still have limitations. Make sure to check the exact specifications of the module. For example, this 1756 OB16 module is a DC output and should not be connected to AC equipment. Also, for high-power equipment like contactors and motors, we usually use the module output to trigger an intermediate relay, and the relay itself switches the power circuit. This protects the module against high current. So to identify an output module, we repeat the same 4 steps as before. 1. Read the part number. OB means output. 2. Identify the output type. Is it DC or AC? 3. Check the number of points. 4. Match the detailed specifications with the connected equipment. By doing this, you will both select the module correctly and prevent it from being damaged. So far, we have reviewed 2 types of digital modules, input and output. Both deal with 0 and 1. But in the industrial world, not everything is 0 and 1. Here we are facing an analog input module. 1756 if4. Let us read the part number again. 1756 means ControlLogix. The letter I means input. But instead of B, here we have the letter F. F stands for analog input. And the number 4 means the number of channels. So 1756, if 4 is an analog input module with 4 channels. Now, the fundamental difference between an analog module and a digital module is that instead of 0 and 1, it receives a variable and continuous value. This value is usually in the form of 4 to 20 mA current or 0 to 10 volt voltage. What equipment is connected to these inputs? Pressure transmitters, which convert the pressure of a fluid into a 4 to 20 mA signal. Temperature transmitters, which either have the same 4 to 20 output or are of the RTD type, where their resistance changes with temperature. Level transmitters, which measure the height of liquid in a tank. And flow transmitters, which show the flow rate or velocity of the fluid. All of these send a variable and continuous signal to the module. Each input channel has 2 terminals, positive and negative. The 4 to 20 mA signal enters the module through these 2 terminals. An important point is that the 4 mA signal in these transmitters represents 0 of the measured value, and 20 mA represents the maximum value. That is why it is called a live signal, because even at 0 we still have current. On the analog module, we also have status LEDs, but they are fewer in number. Usually there is 1 LED per channel or 1 general LED for module health. If the OK LED is on, it means the module is working properly. But to read the exact analog value, we need to refer to the software and see a number between 0 and 100%, or a specific digital range. So to identify an analog input module. 1. Read the part number. If means analog input. 2. Check the number of channels. Here it has 4 channels. 3. Check the type of input signal. Is it 4 to 20 milliamps or voltage? 4. Make sure to verify that the transmitter signal matches the module specifications. If the transmitter is 4 to 20, make sure the module accepts the same.